Good afternoon. Why don't you guys take a minute, turn and talk about all these problems. Try to finish as much as you can. I'll be with you in a moment. Let's do this. So, what did you guys think of the Chapter 9 test on Thursday and Friday last week? What did you think of the Chapter 9 test? All right, we shall see. So yeah, the reason why you don't have the grades in because I wanted everything in this weekend, and I got everything in for geometry in this weekend. Um, I'm gonna grade them pretty much right after class. I have some scans being sent to me. The Thursdays were sent in interoffice mail by a couple of the schools, so I got it graded after class. Sorry, I went to every school to pick them up, so I could grade it over the weekend, but I can't grade it without the first part. By the way, as I transition to the DotCam, are you guys, did you just move from the Learning Lab today? Or are you guys moving to the Learning Lab? Is that just today or is that just today? All right, cool deal. So let's look at exploring inverses graphically first. I want to touch on graphically and algebraically today. I was able to do that last year, and I think that's a good way to jump around and touch on everything. So the inverse is, anybody want to try these top three? What's the inverse going to be of a graph over the line? Okay, the inverse is a what? Okay, well, where's y equals x going to go? Yeah, good. A lot of people either forget this or they need to revisit this. And inverse is going to be a reflection. Good. An inverse is a reflection over the line y equals x. Okay, all lines are equations. Even x equals 5 as a vertical line is an equation. So to take the inverse, and this is actually a algebraic step as well. What do we do in inverses? I think you guys have seen these before, right? Yeah, you switch out the x. I actually like the word switch or swap versus flip, because if you flip, you think reciprocal. And we're about to do a fraction in just a moment with Fahrenheit and Celsius. Yeah. So I promised I gave myself indicators last year, and I'm doing it this year, what pen to work in. So you could probably just about see, I worked in blue pen here. Okay, somebody comes out of the womb, starts swinging a golf club pretty early, very Tiger Woods-esque. So I'm going to go here. I'm not going to put an arrow on the top. I did that last year. That's assuming you're going to live into infinity, which is just not true, unfortunately for all of us. Well, let's stay with the blue. What's the domain of Sharon's graph? I just drew Sharon's graph there, okay? And Sharon's going to be correct in her assessment of what causes what, what's independent, what's dependent. What's the domain of Sharon's graph? What's her domain? Oh, yeah, that's interesting. It is just the natural numbers. However, However, is that really true? Because are there some 1.5-year-olds, are there some 5.5-year-olds, some 6.5-year-olds doing this? Yeah, it's definitely one inclusive because they're not doing anybody that's a complete infant. 1 to 7. Okay, they're only trying out kids 1 through 7. What's the range? What is the range that we have here? I'm going to stay in blue here. What's the range? Yeah, it's going to be 1 to 49. 1 to 49. All inclusive. All inclusive. So here is age, and she says your age is what causes you to be able to hit the ball farther. All right, the older you get, the stronger and more capable you are athletically to swing a golf club. Now, our man here, I think, is a little bit off. Okay, our man Kenny here, I mean, what's the domain of Kenny's graph? He's thinking that distance is what's kind of causing the age. That's one way to think about it, or that age is depending on the distance. It's something you could glean, like if you knew the distance kids were hitting it, you could probably guess what their ages are, but that's not what's causing it. Yes. Well, take a look at the graph. That would answer your question, right? Take a look at the graph. Did I connect the dots, or did I leave them just separately as if it was some sort of piecewise function? Yeah. I mean, they have 3-year-olds that are probably 3.5 or 3 and 10 months old. So what's the domain of Kenny's graph? What's the domain of Kenny's graph? Could fill this in probably. Yep, it'll be right there. What's the domain of Kenny's graph? Yeah, the domain is going to be 1, 49 because he thinks the distance is the independent variable. And what's his range? What's he think the dependent variable is? He thinks the dependent variable is 1, 7. Okay. We've got 36 and 6. So, whoops, sorry, 36 and 6. We've got 49 and 7. Okay. So Kenny's is going out like this. All right, and again, that's not going to be infinity because you can't hit it an infinite distance either. You can't hit it an infinite distance either. So what kind of relationship exists between Sharon's and Kenny's way of looking at the data? Sorry, I should have age here. Yeah, they are inverses of each other. So I'm going to write that big letters here. They're inverses of each other. And that inverses is that y equals x, which I'm just going to connect corner to corner. Okay, that's that line y equals x right there that I'm kind of drawing in black. So over what line is the graph of the data reflected? Well, I just said it. It's y equals x. I put that in black versus the blue and the pencil. Yep, these are inverse functions. So, yeah. So you guys can see that. Make sure you have all that on the page there. Now, let's look at elaborate inverses algebraically. I'll ask you to finish this at the end. I want to touch on inverses algebraically because this is most of the work we're going to do. So we've got Jacques, our friend Jack here, a French foreign exchange student, switching between Celsius and Fahrenheit. Why don't you guys tell me what's the independent and dependent variable based on this equation here? All right, I think you guys have seen these in your middle school science classes. Yeah, so the independent is Fahrenheit. Let's please spell it correctly when it's written right there. Fahrenheit. All right, and what would the dependent be? The dependent would be the Celsius, okay, from this perspective, based on this equation right here, And this equation is based on Celsius, okay, the function of Celsius with the input of Fahrenheit. So knowing Fahrenheit, what would the Celsius temperature be? Okay, that's what this is saying. All right, it's a real-life example of a function. Knowing the Fahrenheit, how do you convert it to Celsius? There's your equation. You guys have worked on that in some of your middle school science classes from before. Well, no, you're almost thinking a little too real world. I'm talking about like if you know the F, if you're just talking about X and Y, in this case X is F, if you just know what the Fahrenheits are, you can convert them to Celsius. So yeah, it is an independent and dependent variable. Measuring outside temperature, you could get both. I mean, even house thermometers have Celsius on one side and Fahrenheit on the other. Yeah. So evaluate C of 90. What did you guys get here? If you put 90 in to this equation, what did you guys get? C of 90. So have a Fahrenheit of 90 degrees, pretty hot, pretty warm, maybe not for Texas. What did you guys get for that? Yeah, let's just keep it 32.2. If it is repeating, it's great. 32.2. Yeah. So up here, everything above this line here, your Celsius measurement depends on your Fahrenheit measurement. Okay, let's say you just have a thermometer that gives only in Fahrenheit. In fact, if you're on your cell phone, okay, the temperature on your cell phone or on these weather apps in America are almost always in Fahrenheit unless you change it, unless you change the setting. So if I was to ask you, okay, convert that Fahrenheit that you see on your cell phone, the current temperature, convert it to Celsius, you'd put it in that function. Now, so you and Jacques are taking a trip to Paris. Okay, so now you're in Jack's country here. Okay, you're on a trip to Paris, a wonderful city, one of the greatest cities in the world, and they use Celsius temperature scale. So you need to write a function. We're going to talk about that in a second. What would be the independent and dependent? So your cell phone, let's say it just switches to not only the time in Paris, but it also switches from Fahrenheit to Celsius. What's independent and dependent now? What's independent and dependent? Yep, so which one's which? What's going to be the independent now? We are in Paris, France. What's our independent going to be? It's going to be Celsius, and our dependent is going to be Fahrenheit. Because we're going to know what this is, we got to see how it yields this. In America, we know what this is. We have to put in this calculation to yield that. So how are these functions in the original function related? Well, you guessed it. They are inverses. They're inverses of each other. So what did you guys get for 5? What's the function for the new situation? What did you guys get for 5? The function of the new situation. Yeah, this is something you could have looked up too to check your work, but hopefully you did it yourself. So yeah, your answer is going to be yes. You're 9/5. Oh, we're getting all different answers here. We're getting all different answers. Oh, even I got fooled. Wow. Okay. So what do we have here? We started with, let me put this in pencil. We started with C equals 5/9 F minus 32. So we get F on the other side of the equation. How do we get F on the other side of the equation? Well, we get it by itself. So we multiply both sides of the equation by 9/5. and that should yield 9/5 C, and that should equal F minus 32. Add 32 to both sides, and your function for the new situation should be F equals 9/5 C plus 32. So there's your function for the new situation, because you're going to be inputting Celsius now. So Celsius is going to have some stuff done to it. Okay. And you guys have probably seen these formulas in your science classes. That's the third or fourth time I've mentioned that. So it says substitute some values to check your function and make sure it's working. So I want you guys to put in 5. Okay, put in 5 for C. Let me know what that yields in the chat box in just a moment. Okay, anybody else? You getting 41 degrees? So yeah, it's going to yield to Fahrenheit. You have F equals 9/5. We plugged in 5 for C. Yes, we did you a favor there. Plus 32. And that indeed yields Fahrenheit equals 41, and that's in degrees, just like Celsius is. Okay, so now what do we want to do to check? What do we want to do to check to make sure that these inverses work? What do we want to plug in for F in the other function? What do we want to plug in for F? Yeah, we want to plug in 41 now for not this function, because we already know what C would be if we plugged 41 in. We want to plug it into this guy here to yield a Celsius. So why don't you plug 41 in for F from that original equation? What is that called, McKinley? No. Close. What happens when you plug into one equation and then plug into another sequentially like that? We've done them earlier. Close. Close. No. Oh, is Rhea going to get it? There we go. Yep. What did Rhea just put? Perfect, Rhea. Yeah, what do we call that? Rhea put it algebraically. Oh, come on. We did a bunch of them. Well, you got the first 4 letters right. Yeah, composition. Very good. So what'd you guys get for F equals 41? What'd you get for F equals 41? You had to plug it into the C equals 5/9, and we put 41 minus 32. Okay, yes, we did a favor for you there, so you'd have a 9 to cancel out, and your C should have been 5 degrees. And that makes sense, because remember, what's 0 in the Celsius scale? What's 0 in the Celsius scale? Yeah, it's 32 degrees Fahrenheit. So if you went about, I know it's not the same scale, but if you go about, if you're talking about 9/5, that's almost 10. 9/5 is almost 10. If you go almost 10 above 32, you got 41. Makes sense. Okay, just always ask yourself if these things make sense. Celsius is just above freezing. So 5 degrees is just above freezing in Celsius. Fahrenheit is 41 degrees, is just above freezing, right? Not a whole lot. A bit, but not a whole lot. Good. So why don't you guys finish up the last 5 minutes here? Do number 5 through 12. Go back to the explore. Go back to the explore inverses graphically. We did the front side of the page. You guys do 5 through 12 on the back. And then we'll pick up the rest of this tomorrow. Let me know if you have any questions in the chat box. Great job today.